Hello everyone and welcome to your first maths lesson of the week. We are starting a new unit now. This unit is going to build on our knowledge of fractions, and we are going to be including percentages as well. We're also going to be working with fractions in some different ways. So this is a chance for us to revise some of our fraction knowledge as well as to build on it. So here is a glimpse of what you can look forward to this week. The first lesson is going to be all about adding and subtracting fractions when the denominator is the same. So this is going to be a very simple and straightforward lesson for the vast majority of us, but we just need to make sure that we have this knowledge in our head. First is your arithmetic for this week. Now, because it's the first one of the week, I'm going to help you out with how you are going to set these out, and just a little word to the wise. So let's start with question 1. Which is here. Okay, so we are moving on now to multiple digits multiplied by a 2-digit number. So we need to set it out in a column method, just like we did before. And we start by doing 2 multiplied by 132. So we're just ignoring the 1 for now. So we know that 2 times 2 is 4, 2 times 3 is 6, 2 times 1 is 2. Then what I'm doing is I'm going to do 10 times 132, because I know that this number isn't actually 1, it's 10 because it's in the tens column. Now, to make this easier for myself, because I can see it's one column over, I put a place value holder here. And now I do 1 multiplied by 2, which is 2, 1 multiplied by 3, which is 3, and 1 multiplied by 1, which is 1. So what I've done here is 132 times 2 and 132 times 10. What I need to do is add them together. And you are going to work out the answer for yourself and put it in your arithmetic. For this second set of questions, these are place value style questions this week, the number 2 questions. Now, the idea is for you to be able to do these in your head, to be able to identify, for example, that this is 6 ones and there's 6 ones here. Do I need to write the whole thing out as a column like that? Well, no, I don't. I should be able to do these ones in your head, to be able to do them mentally. The last one, sticking with rounding and just remembering that we are rounding to the nearest 10. So we are looking at the tens column and the column to the right. So the rest of the stuff is going to stay the same. And then that 47, what is 47 to the nearest 10? Am I going to round up or am I going to round down? Please pause the video now, go over to your arithmetic sheet, which is under the maths for this week, arithmetic, and then arithmetic answers. Okay, key vocabulary for the week. We are going to be keenly looking at working on numerators, denominators today, and fractions as part of a whole. So this is our key vocabulary for today. If there are any of these parts you're unsure of, this might be the time for you to pause the video and have a discussion with the person with you, or have a think about what they are. They will come up in the video though, so don't worry if you're unsure. Okay, so here we have a couple of questions which are represented by rods. So this first rod, wish that would stop happening. This first rod is worth 1. The grey rod is worth 1. So what is the yellow rod worth? Well, as you can see, the yellow rod is half the size of the blue rod. So this rod that I've drawn in here is also going to be worth half the size, isn't it? I've got 2 halves. So I've got a half plus a half equals a whole, as we can see. Now, over here with this problem, I start with 1 again. What size is the red rod? Well, I can see that the red rod is a fifth. So I know that I've got a fifth plus a fifth plus a fifth plus a fifth plus a fifth. Now, what we're going to be doing in this lesson today is we're going to be adding fractions where the denominator is the same. Now, we don't need to be simplifying, we don't need to be finding equivalent fractions. All we are doing is some really simple, straightforward math. Let me talk you through it for a little while. In this first equation on the left, a half plus a half, when I add two fractions together, if the denominator is the same, the denominator is going to stay the same. All I am working out, all I need to do is add the numerators together. So for this first one, I need to do 1 plus 1 to give me the answer 2. 1 half plus 1 half equals 2 halves. Now that makes sense logically, doesn't it? I've got 1 half and I've got another 1 half. So putting them together, I've got 2 halves. What do I know then about fractions where the numerator and denominator is the same? I know that that is equal to 1. 2 halves, 3/3, 4 quarters, 5/5, 6/6. All of these fractions are equal to 1, which you can see clearly on the left. It is exactly the same if I'm adding multiple fractions of the same denominator. So when adding fractions, we are not adding the denominators together. If the denominators are the same, which they are here, it stays the same in the answer. So my answer is going to be an amount of fifths. So I've got 1/5, add another fifth, add a third, another fifth, add another fifth, add another fifth. So I've got 1, 2, 3, 4, 5 fifths. 1 plus 1 plus 1 plus 1 plus 1 is equal to 5. And as you can see, the numerator and denominator are the same, which is why this is equal to 1. So moving on slightly, we are going, can you work out how I'm going to work out the value of this black rod? Well, you can see that the black rod is the same length as the yellow rod and the red rod put together. So it's equal to 5/9 add the 2/9. So what did I learn from the previous slide? Well, when the denominators are the same, it stays the same in the answer. So what I'm doing at the moment is I'm counting ninths. Ninths is almost like my unit. It stays the same. So I've got 5/9 here. We're going to add on 2/9. What is 5 add 2? Well, it's 7. 5 add 2 equals 7. Therefore, 5/9 add 2/9 is equal to 7/9. Exactly the same here. I've got the same problem, but just the inverse. I've got 2/9 plus 5/9 is equal to what? Well, just like before, in the question, the denominators are the same. Therefore, in the answer, it will be say the same. I have 2/9 plus 5/9 equal to 7/9. Fortunately, when subtracting fractions where the denominator is the same, it is just as simple. I can see I have a whole bar which is worth 7/9, and I can see that this yellow bar is worth 5/9. What do I have to do to find that red area? Well done if you're able to identify that what I'm doing is subtracting the 5/9 from the 7/9. 7/9 subtract 5/9 is equal to, well, fortunately, I can see my denominators are the same. Therefore, all I need to do is keep the denominators the same in the answer. I'm not adding the denominators together. The denominator stays the same in the answer. And I'm just thinking at the moment about the numerators. 7 subtract 5 is equal to 2. Therefore, 7/9 subtract 5/9 is equal to 2/9. And over here again, let's see the inverse. 7/9 this time. Subtract 2/9. Well, once again, I can identify that the denominators are the same, therefore they stay the same in the answer. And I'm just focused on the numerators. 7 subtract 2 is equal to 5. Therefore, 7/9 subtract 2/9 is equal to 5/9. Here are some very simple talk task problems for you to do. The idea of these is that you use the language. Okay, so if you are working on your own, you can stop and I want you to say them out loud. If you are working with someone, maybe you can take it in turns, or you can but the idea is just to be saying them out loud all the time, because the key bit of learning from today is that when the denominators are the same in the question, it stays the same in the answer, and it is the numerators I'm looking for to answer my question. For example, 2/9 plus 1/9 is equal to what? Well, I know that 2 plus 1 is equal to 3. Therefore, 2/9 plus 1/9 is equal to 3/9. Can you pause the video and do the same for the next two, please? Okay, welcome back. So here I have 1/5 plus 2/5 is equal to something. Well, I know that 1 plus 2 is equal to 3. Therefore, 1/5 plus 2/5 is equal to 3/5. And again for the bottom one, 6/11 plus 4/11 is equal to what? Well, I know that 6 plus 4 is equal to 10. Therefore, I know that 6/11 plus 4/11 is equal to 10/11. Well done if you got those. Because these are fairly simple, we will encounter problems like this as word problems. So let's have a look first at what we have here. Well, we have a pizza question as always. So we have this pizza, it's been cut into 8 slices. Therefore, we know that each of those slices is an eighth. Okay, so we start with 8/8 of a pizza. Bella eats 3 slices and Lara eats 2. Firstly, what fraction of the pizza has been eaten, and then what fraction is left? Okay, so let's work it out. So firstly, what fraction of the pizza has been eaten? Well, I know that Bella eats 3 slices, so she eats 3/8 of the pizza. 1/8, 2/8, 3/8, and Lara eats 2. 1, 2. So altogether, how much has been eaten? Well, I know this is an altogether question, so I know that I'm doing 3/8, add the 2/8. What do I know from my learning? Well, sorry if I'm starting to sound like a broken record, but I want us to all know this. When I identify that the denominators are the same, it stays the same in the answer. I have to add the numerators together. So my answer is 5/8. What fraction then is left? Well, I started with 8/8 of a pizza, and I've subtracted by eating 5/8 of the pizza. So I can see that the denominators are the same, so it stays the same in the answer. And I'm doing 8 subtract 5, which is 3. This time I haven't got the pizza to help me out, so I'm going to have to just write this one out. There are 7/8 of a pizza, and I eat 2/8 of the original pizza. Now, in fraction questions, sometimes it will say to you, I ate 2/8 of the original, and sometimes it might say I'll eat 2/8 of what's left. Now, that second one is much more difficult to answer, and that was something that we'll get to much later. That's dividing fractions, okay? We don't need to worry about that now. So for our questions, we are talking about the original pizza or box of sweets or something like that, okay? So there were 7/8 of a pizza, and I ate 2/8 of them. So I've subtracted 2/8 of them by eating them, by taking them away. So how many is left? Denominator's the same. Numerators 7 subtract 2 equal to 5. Moving over then to your independent task. Please make sure that you pause the video now and have a proper read of this. Let me show you your independent task. Please read this information at the top. Please just answer as an improper fraction. Please do not feel the need to simplify or give any equivalent fractions. This is quite a quick independent task. Challenge 1 and challenge 2 are just addition and subtraction problems. Challenge 1 is very simple. Challenge 2 is a bit less simple, but still using the exact same rules as before. Okay, so you just need to write it out on a piece of paper to work them out. Some of them, or most of them, you'll probably be able to do in your head. Okay, the only challenging bit of this lesson is challenge 3, because it's asking you to use your word problem skills as well. Think about word problem vocabulary. Okay, things like all together or how many left. And please make sure you read the question. If the question is asking you to answer in a certain way, for example, in question 3, it's asking you to answer as a fraction of a kilogram. So my answer is going to be, for example, 1/8 of a kilogram, or 2/10 of a kilogram, or something like that. Okay, nice and straightforward start to this topic. Over to you.